Okay, section 1.2 is data classification. So there's two main ways that we classify data. There's qualitative data and there's quantitative data. So for qualitative data consists of labels, attributes, or non-numerical entries, and quantitative data consists of numerical measurements or counts. So quantitative, like quantity, typically anytime we see a number, it's going to be quantitative. So for example, let's determine which of these data are qualitative and which are quantitative. So for the first one, the price of a car. So price of a car is going to be numerical. This is going to be quantitative. For B, the make and model of a car. Make and model of a car, that's going to be qualitative. And it's qualitative because those are labels. For C, we have temperature. Temperature is going to be a numerical measurement, so that's going to be quantitative. And for D, vehicle speed is also going to be a numerical measurement, that's going to be quantitative. For E, we have shape. So shapes are qualitative. And F, odor, so smells are going to be qualitative also. Length are numerical measurements. Lengths are going to be quantitative. And for H, so H we have jersey number. So even though this is a number, this is not quantitative. This is going to be qualitative. And it's qualitative because jersey numbers are essentially labels. So it's not quantitative, but it's qualitative. So a little bit tricky for that last one. All right, so for the next thing, we're going to have different ways that we can kind of categorize data. So we call these levels of measurement. What this does is it helps us determine what calculations are meaningful for that data. So there's going to be 4 different levels of measurement. So the first one is the nominal level of measurement. This is the lowest level, so they're going in order from lowest to highest level. And what I mean by levels of measurement, the lowest level means that calculations are the least meaningful. So the higher up we get, the more calculations we'll be able to perform on the data. So for the nominal level, just like the name actually suggests, nominal means name. This is going to be qualitative data only. So this is only going to be qualitative data. And this means that data is categorized using names or labels. So it's just going to be categorized using names or labels, and that's it. Qualitative data only. So the next level is going to be the ordinal level. So this can actually be qualitative or quantitative. So that one could be either or. And for the ordinal level, just like once again the name suggests, ordinal or order, this means that the data can be put in order. So there's some order to the data. For 3, for the interval level, this is going to be quantitative only. So only quantitative. And the data can be ordered. It doesn't have to be though. And just kind of like this name suggests, for interval, meaningful differences in the data exist. So meaningful differences in data can be calculated. So differences essentially meaning, since we're dealing with numerical entries, meaning that we can subtract two values and it actually means something, which we'll see when we get to an example. And for the last thing here, if we have a entry that is a 0, a 0 entry is not inherent 0. So we'll see what that means on the next page, because I'm going to bring it up again for this last level here. So essentially each level is going to absorb the previous level's information. So for the last one here, we have the ratio level. So this is the highest level, meaning we can essentially perform the most meaningful calculations to the data. So this is also going to be quantitative. So numerical values only. And once again, this can be ordered. It doesn't have to be ordered, but it can be. And just like interval level, meaningful differences in the data can be calculated. So it absorbed the interval levels. And where this one gets its name is that the ratio of data entries, two data entries, can be formed and is meaningful. So ratio means division. So if we take the ratio of two entries, that actually means something. And the last thing here is a 0 entry. If we have an entry of 0, a 0 entry is an inherent 0. Okay, so those are the 4 levels of measurement. So let's go back to this inherent 0 concept. So an inherent 0 is a 0 that implies none. So we actually kind of have two definitions of 0 when we talk about 0. Either we say 0 as in none, or 0 that it is on essentially an interval. So let's see what we mean with an example here. So let's determine if the following zeros represent inherent zeros. So for the first one, if we have $0 in a bank account, so we ask ourselves, does $0 mean we have none? Is that 0 a none? That does represent none. That represents no money in a bank account. This is an inherent 0 because it represents none. So if it's an inherent 0, going back up here a little bit, that means it would be at the ratio level. And for the next one, for B here, if we have a temperature 0 degrees Celsius, 0 degrees Celsius, that does not represent no temperature. That's just on an interval. So this is not an inherent 0, because it does not represent none. So that would be the same case for 0 degrees Fahrenheit, obviously. However, if we had 0 Kelvin, 0 Kelvin would be an inherent 0, because that's the temperature scale representing no heat. So that would represent an inherent 0 for 0 Kelvin. Okay, so let's do some examples to see what levels of measurement these data sets are on. So for the first one, if we have the top 5 grossing movies of 2012, so the top 5 grossing movies of 2012, the first one is The Avengers, second one Dark Knight Rises, third one Hunger Games, fourth Skyfall, fifth Twilight. So we want to think, what kind of data we have? Well, this is qualitative data. So since this is qualitative, this can only either be ordinal or nominal. So ordinal or nominal. Since the data is in order, this has to be ordinal. So this is at the ordinal level. Okay, and then for B, for movie genres, so we have some movie genres. We have action, adventure, comedy, or horror. So once again, this is qualitative data, so it has to be nominal or ordinal. There is no order to this data. So since there's no order to this, this is the nominal level. So the first one was ordinal, second one is nominal. For C, so we have the New York Yankees World Series victories, and these are the years that they won the World Series. I didn't write them all down, but I started to write them down. So 1923, 1927, and so on. So these are years. So these are numbers. So this could technically either be ordinal, interval, or ratio. So this is going to either be interval or ratio because we can do meaningful differences between the two numbers. So let's say we wanted to look at 1923 and 1927. If we subtracted those, 1927 minus 1923, we get 4, a difference of 4. That difference of 4, that's saying it's been 4 years since they won the last World Series. So that's a meaningful difference. So that could be interval. So it's either interval or ratio. We can go to narrow it down between interval or ratio. We can think of the inherent 0. So we go to that 0 entry. So if there was a year 0, which technically on our calendar there isn't even a year 0. If there was a year 0, we want to think, does that imply none? That does not imply none because that's just on an interval. It's not saying that there's no years. It would just be the year 0. So the 0 entry is not inherent. So that means this has to be at the interval level. So at the interval level. And then for D, for the next one, for D, we have the 2017 NFL passing touchdown totals, and we have the quarterbacks and the number of touchdowns that they threw in order. So these touchdown totals are obviously quantitative data, so technically it could be ordinal, interval, or ratio. Meaningful differences can be calculated. If we did the top 2 quarterbacks here for passing touchdowns, Russell Wilson and Carson Wentz, 34 minus 33, that means there's Russell Wilson threw 1 more touchdown, so a meaningful difference can be calculated. So maybe let's think about the inherent 0. So if somebody threw 0 touchdowns, if I threw my name on the list here and put Brian Beyer and I threw 0 touchdowns, so 0 touchdowns, this obviously is an inherent 0. Because it represents none, through 0 touchdowns. So that means this would have to be at the ratio level of measurement. So another way to think about it, where it would get its name from for the ratio level, if somebody threw 30 touchdowns and somebody else threw 10 touchdowns, we would say that if the person who threw 30 touchdowns threw 3 times as many touchdowns as the person who threw 10 touchdowns, that is a ratio. That was 30 divided by 10. That's a ratio, which is 3. So we can think of it by forming the ratio if that's meaningful, or we can think of it with the inherent 0. Okay, for E, the average temperature for each day of the week in Fahrenheit. So average temperature, so it's quantitative, so it could be ordinal, interval, or ratio. Obviously, we can have meaningful differences that are calculated because we can calculate the difference between 2 temperatures to see how much more one is than the other one. And then we can think about it in terms of the inherent 0. So we already said this earlier. 0 degrees is not an inherent 0. So that actually means that this has to be at the interval level. Okay, so if you wanted to think about it as a ratio once again to see if it's at the ratio level and not use the inherent zero, we could take two temperatures, let's say 10 degrees and 50 degrees. 50 degrees is not 5 times hotter than 10 degrees, so that ratio is actually not meaningful. We can do the ratio because they're numbers, but they're just not meaningful. Okay, so let's do one more here. So we have the height of trees in a neighborhood in feet. So we just have all these numbers which represent how tall the trees are. So once again, this is obviously quantitative data, so it could be ordinal, interval, or ratio. Clearly it can be interval, because if we took the difference between two numbers, that would say how much taller one tree is than the other one. So we have to think about between interval and ratio level. So we can go to the inherent zero. So 0 feet here, let's pretend like we had 0 feet. So if it's 0 feet tall, that actually does represent an inherent zero. So since that does represent an inherent zero, that means we are at the ratio level of measurement. Also, if we had a 20-foot tree and a 40-foot tree, the 40-foot tree is 2 times taller than the 20-foot tree, because 40 divided by 20 is 2, which is a ratio, so ratio level. The ratio is meaningful. Okay, so those are the 4 different levels of measurement, and that's it for section 1.2.